So citizen science is not at all a new concept. In fact, it's been around for quite a while. A prime example of this is the American Association of Variable Star Observers. This organization has been around as of this year for 100 years, and during that time became the primary source for data on variable stars. It is interesting to note that AAVSO has not only been a primary source for high quality data, but the quantity of data has been extremely impressive. And as a matter of fact, in their 100th year, they registered the 20 millionth submission of observation to their database. That's a lot of data. So why would you go about going to the time and effort of instituting a citizen science program in your mission? There are what I consider to be four fairly obvious reasons. One of those has to do with the sheer amount of data that you may encounter. We've seen a number of cases now where missions and the experiments aboard those missions can produce a huge amount of information that can quickly overwhelm the researchers and all of their graduate students. So in a number of cases, it can be very advantageous to take advantage of this resource of citizen scientists out there to get through that data. Another circumstance could be, or another instance could be, to take advantage of special circumstances. You may have special events in your mission that may be of limited duration or limited observability. And so the ability to get as many eyes as possible out there can be a huge benefit. Point number 3, okay, this one's scary. I will admit it, hang with me, but the idea of providing mission operations support. Okay, I know you don't want to turn over your spacecraft or your observations to a class of third graders, but trust me, I'll show you instances where this can actually work to your advantage. And finally, providing background science data. As your science teams work to come up with their theses, they will come up with a number of instances where there can be supportive science that can be done here on Earth that can be of direct benefit to the mission. So those are the four obvious ones, but I want to bring to mind one other, and that is when your neighbor or your neighbor's children become directly involved in a mission. This becomes their mission. They become personally involved with it, they identify with it, and they become our best advocates. And in these political and economic times, that can be a significant consideration. You want advocates for your mission. So let's take a look at some examples. Under the category of processing large amounts of data, a wonderful example was the Stardust at Home program. So Stardust, in its sample return, brought back trails from cosmic dust, but they were in 700,000 fields, each consisting of 40 images. And it turned out that the identification of these tracks through the media was something that was not well suited for computer algorithms. You really needed the pattern recognition of the human brain. That's a lot of data to plow through. And so what they instituted was this Stardust at Home program where people at home, thousands of people at home, were logging in and they were finding these trails of cosmic dust through the medium. Very effective use of citizen science, and it really got the people charged up about this mission. It was their mission. Another great example, we heard Mark Robinson today talk about the amount of imagery coming back from L Rock. Phenomenal amount of imagery. Trying to interpret all that imagery is a significant task. But with the MoonZoo program, again, thousands of people out there are having these images delivered to their computers at homes, and they are helping with such things as crater counts, searching for boulders, and identifying really key, interesting features that we need lunar scientists to look at. So now, taking advantage of special circumstances, and I'm going to go back to Stardust. Stardust did a lot of things right. And when Stardust returned its sample container, that sample came in faster and hotter than anything else we have ever brought back to the surface of the Earth. And there were people, especially people here at Ames, who were very interested in the performance of that heat shield, of the thermal protection system. And so NASA published a map, and they distributed it to the public. And they said, if you live anywhere near, or can get anywhere near this reentry path, please show up with your cameras, your video cameras, capture this data for us. And you know something? They did. And I know there are people here in the audience who were out there for this specific event. Very, very exciting. Another example of taking special advantage of circumstances was the search for the Cross Plume. We had amateur astronomers and students all around the western United States and the Pacific looking for that plume. Okay, as you may recall, it didn't show up, but after the initial amount of snarfling that one heard, there was an amateur astronomer, actually here in the Bay Area, a gentleman named Ken Lum, who pointed out on the message board, hey, you know something? A negative result can be pretty interesting. And as we heard from Jen Heldman earlier today, that negative result did end up being very interesting. Mission operations support. Okay, the amateur astronomers in Cross didn't come out empty-handed, thank God. It turns out, before we launched Cross, one of the things that we knew was that the poles of the moon were among the worst mapped areas on the entire surface of the moon. And the lighting and shadowing conditions there at these areas of primary interest to us were pretty badly known. So Diane Wooden went up to Mauna Kea and started doing a series of observations, but she ended up recruiting the amateur astronomy community. Rick Baldridge, who is in the audience here, helped coordinate that. And one of the wonderful things about amateur astronomers today is they are able to stack multiple images, and they do image deconvolution and wavelet processing that results in imagery of resolution that you would swear could only come from lunar orbit. We got good information from this. This helped us plan our mission. One of my favorite examples. The Lewis Center for Educational Research operates the Gavitt program, where students take control of giant 34-meter dishes down at Goldstone. They do it now for radio astronomy, but they're able to take remote control of these dishes from their classroom. But the heritage of these dishes is spacecraft communications. And so we had over 1,700 students during the course of the Cross mission using these assets, the DSS-13 dish, to track and monitor the health and status of our spacecraft in flight. They were listening at times that we did not have time scheduled on the DSN. We got direct benefit from having these students listening and monitoring the health and status of our spacecraft. They also did Doppler studies. When we did trajectory correction maneuvers, they were able to tell us our delta V. That's pretty cool. Doppler Shift has been demonstrated in classrooms any number of times. I happen to think this is the coolest demo of the Doppler Shift I've ever seen in a classroom. Another really fun thing, there was debate before the mission as to the ability to track Cross in flight. We knew we could do it with a large telescope. But then there was the question, would amateur astronomers be able to do it? And this was met with a great deal of, I don't think so. But again, Rick Baldridge, who's in our audience here and has had some experience in this, said, yeah, we can do that. And it turned out he was right, as the L-Cross was in flight. And you can see, I'm hoping you can see here, note, this is with a 16-inch telescope, also here. So we started out getting really good images with 16-inch telescopes, and as time went on, there was a competition almost to see how much better it could get. And the record ended up being 78 millimeters. That's pretty impressive. So, background science. One of the things we're planning to do with LADI. Turns out telescopes in the 8 to 16-inch range are ideal for recording impact flashes of meteoroids on the moon. And we've heard in a number of talks today how meteoroid impacts are significant for us in understanding the dust and atmospheric environment on the moon. And the LADI mission is therefore looking to correlate the results of their instrumentation with as many eyes as we can get watching for these meteoroid impacts. But again, the major flashes that you see are caused by things that are far larger than the typical impact. Most of the impacts on the moon are too small, but we can make inferences by looking at meteors here. So as we do meteor counts here on Earth, we can make inferences as to what's happening on the moon. So in summary, lessons learned. Provide multiple levels of entry. If you have a great telescope that can detect flashes, great. If you have a good reclining lawn chair, then you can do meteor counts. Keep expectations realistic. That's hard to do when you're bombing the moon, but you keep repeating it. Provide enhanced value by leveraging existing programs. Find out what's out there. Don't reinvent the wheel. One of the investments you do have to make is make sure that your mission science team is talking directly, providing briefings to this community that's working with you. Recruit your coordinators and moderators from the citizen science community. They have a level of credibility that sometimes we do not have. And provide incentives, launch passes, mission patches, those kinds of things work wonders. And never ever underestimate the capabilities, motivation, and enthusiasm of the amateur astronomy community. Thank you very much. Yvonne, I made it.
Okay.
Bob Solheim, Pratt & Whitney Rocketdyne, retired. I have a question. Is there a common forum that someone can go to find out opportunities to support these various missions?
That was a topic of discussion the past 2 days at we had an education and public outreach retreat here. And so we're looking to really formalize and find a centralized way that you can find opportunities for participating in these programs. However, right now I would recommend looking at specifically the Association of Lunar and Planetary Observers, ALPO. They have a number of excellent opportunities. Also, take a look at the International Meteor Organization and the American Meteor Society.
Okay, thank you.
Mm-hmm.
Joseph Blasio, was there any follow-up done with the people who looked for the Cross Plume? Was there any follow-up?
They all committed suicide.
I think, to finish the question, would they participate again, or did they understand the significance of the negative results?
So, you know, I'm going to put someone on the spot here, and so I see one of them in the audience here. So I'm going to deflect the question to him and let him answer that. Rick Baldridge, would you mind standing up and tell us what you think?
I was involved with organizing some of the amateur community in the local colleges for the L-Cross Impact, and I think